All right, so this is the test review here. So let's go ahead and start. This one says to factor the polynomial completely. All right, so make sure you do have formulas available for this. So this one right here is going to be a sum of cubes. So I'm going to make this into x to the third power. And 5 to the third power is 125. So this is my a and this is my b. So the formula for this, if you recall, is a cubed plus b cubed, which is a plus b, a squared minus ab plus b squared. So a plus b, so x plus 5. And then a squared minus ab, so a is x, so that's x squared, minus a times b, which is 5 times x, plus b squared, so 5 squared is 25, and now it's factored completely. All right, for the next one, we have a difference of cubes, so it's very similar to the one we just did. So we're going to have a minus b this time. And this is the formula that you would follow to do it. So this is going to be y cubed. I can just put that here actually. Minus 4 to the third power is 64. So there's my a and my b, so y minus 4. Square it, plus sign, ab, so y times 4 is 4y, plus sign b squared. B squared is 4 squared, which is 16. All right, on to the next one. This is the same one. It's this one here. So 27, the cube root of 27 is 3, and then x to the third plus 2 cubed. So we have a plus b again, so 3x plus 2. So a squared, so 3x squared is 9x squared. Wrong one. Minus a times b, so 3x times 2 is 6x, plus b squared, 2 squared is 4. All right, on to the next one. For this one here, we are going to factor out the GCF because I noticed they're all divisible by x. So now we have x squared plus x minus 6. There are no, so that was the greatest common factor. There are no special cases here, so we go to the x method. So I'll do that right here. So b is 1, a is also 1, and then 1 times negative 6 is negative 6. So my factors that add to 1 and multiply to negative 6 are going to be 3 minus 2. So we have x times x plus 3 times x minus 2. All right, on to the next one here. So it is in standard form. We look for our greatest common factor. In this case, they're both divisible by 2. And they have x squared in common. So 2x squared times x squared is 2x to the 4th. 2 times negative 81, and x squared is there. That's good. This is a difference of 2 squares. So in case you need this formula, it is a squared minus b squared, which is going to be a plus b, a minus b. So you just pretty much take the square root. So we have 2x squared. We take the square root of this, which is x, and the square root of 81, which is 9. And we write that twice, and one of them is positive and one of them is negative. Then we make sure it is factored completely. In this case, it is. So then we just leave it alone, and this is our final factored form. All right, for the next one, there are 4 terms. So automatically, when we see 4 terms, we automatically try factor by grouping first. So I'm going to group the first 2 and then the second 2. So the GCF from the first 2 terms is x squared. And that's going to leave us x plus 6. Here we have a positive 3 in common, leaving me again with x plus 6. So you notice these are the same. So we'll put that in front. And then what's left over we put in the second set of parentheses, so x squared plus 3. And that is completely factored. There are no special cases here. All right, on to number 7. So for number 7, again, we have 4 terms, so we automatically try factor by grouping. Here we see we have x squared in common. X squared times x is x cubed, x squared times negative 1. Here we have positive 2 in common, again leaving us with x minus 1. These parentheses are the same, so we factor those out in the front. leaving us with x squared plus 2 in the second set of parentheses. I cannot go any further, so this is completely factored. All right, for this one, again, 4 terms, so we're going to try factor by grouping. Remember, if factor by grouping did not work, then we would do the rational root theorem. So factor out x squared. That leaves me with x plus 2. Here, this has to be a positive x, so we're going to factor out the negative for sure. Then 4 and 8 are both divisible by 4. Again, leaving me with x plus 2, so you notice these parentheses are the same. Factor that out. Remaining is x squared minus 4. At this point here, I see that this is a difference of 2 squares. So I'm going to take the square root of both sides, or the square root of x squared and the square root of 4. So we'll leave this x plus 2 alone. Square root of this is x, the square root of 4 is 2. 1 positive, 1 negative. This answer is acceptable. You can also write it as x plus 2 squared times x minus 2 since there are 2 of them. I'm running out of space, so I'm going to leave it like that. Okay, so number 9, it is in standard form. There is a greatest common factor. They're both divisible by 9. 9 goes into 36 4 times. Here we do have a difference of 2 squares. It's just that this is a higher power. So square root of x to the 4th is x squared. Square root of 4 is 2. 1's positive, and 1 is negative. Now this may be squared, but this is not a perfect number, a perfect square, so this cannot be a difference of 2 squares. This will be my final answer. All right, up to number 10. So for number 10, once again, standard form, yes. Greatest common factor, they both share 2x squared. 2x squared times x squared is x to the 4th. 2x squared times 2. And it doesn't look like I can go any further than that. Yeah, they're completely factored. All right, on to the next one. Here we're going to do the x method. It's in standard form. There is no greatest common factor. There is no special cases, so we go to the x method. So negative 4 at the top, dividing by a, which is 1, and then 1 times negative 5 is negative 5. So now what numbers add to negative 4 and multiply negative 5? That's going to be 5 and 1 with the negative 5 there. From here, first we would probably write it as x minus 5 times x plus 1, but x times x is x squared, not x to the 4th, so to fix this, we just square the x in both of them. And there is nothing else I can go further than that, so this is my final answer. Now, if you want to verify that this is correct, x squared times x squared is x to the 4th. When you FOIL the rest out, it will work out. All right, on to number 12. Number 12 is the same process. You're going to do the x method. So 9 at the top, dividing by a, which is 1. And then 1 times 20 is 20. So the numbers that add to 9 and multiply to 20 are 5 and 4. This time, when I write, I'm going to go straight to the c to the 4th, so it's going to be c squared plus 5 and c squared plus 4. And remember, this is no difference of squares because that's a plus sign, not a minus sign. All right, on to the next page. So my page may look a little bit different than you. I spaced it out so I could work them out a little bit better. All right, so here's number 13. These ones do say to solve now. So the first thing I'm going to do is make sure I set it equal to 0. So I'm going to subtract the 56x over. Okay, we're going to factor out the GCF here. So they're all divisible by 2x. That leaves me with x squared plus 12x minus 28 equals to 0. I'm going to do the x method up here. So we have 12, a is 1, and 1 times negative 28 is negative 28. So my factors are going to be 14 and 2, with the 2 being negative. So now we have 2x. This is going to be x plus 14 and x minus 2. Now you can set each one equal to 0, but you can see I'm running out of room, so I'm just going to solve it. This is x is equal to 0, negative 14, and positive 2. All right, on to number 14. Once again, we're going to set it equal to 0, so we're going to move 56x cubed over. So 2x to the 5th minus 6x to the 4th minus 56x cubed is equal to 0. We're going to start by factoring out 2x to the 3rd, because that is what they have in common. So this will give me x squared minus 3x minus 28 is set equal to 0. I'll perform the x method up here. So negative 3 on the top, my a value is 1. And then 1 times negative 28 is negative 28. So my factors are going to be 7 and 4, with the 4 being negative. So now we have 2x to the third, x plus 7, x minus 4 is set equal to 0. So when I solve when I set each one equal to 0, 2x cubed equals 0 is going to be 0, negative 7, positive 4. And you can always verify these by setting them equal to 0, like this one. Take the cube root. Cube root of 0 is 0. 0 divided by 2 is still 0. All right, now this one has 4 terms. Again, we're going to bring everything to the same side as the highest power, so y cubed minus 8y squared minus 9y plus 72. Since there's 4 terms, we're going to try factor by grouping first. If that does not work, then I will go into the rational root theorem. So I see these are both divisible by y squared. This, negative 9. And we notice these are the same now. So this is going to be y minus 8, because these are factored out, and then we have y squared minus 9. I see a difference of 2 squares right here. So that's going to be y, square root of this is y, square root of 9 is 3, so y plus 3, y minus 3. So my solutions will be y is equal to 8, negative 3, positive 3. When I set each one equal to 0 and solve individually. All right, on to number 16 here. So for number 16, same thing, we're going to set it equal to 0, so I'm going to subtract 22x cubed over. And when I subtract 22x to the third, hopefully you see that I'm actually taking it away from something. So this will be 12x cubed minus 48x is equal to 0. GCF, they both divisible by 12 and x. And then this is going to be x squared minus 4 is equal to 0. This is a difference of 2 squares. So the square root of this is x, the square root of this is 2. Once again, one positive, one negative. So then my solutions would be, if I set this equal to 0, it would be 0, negative 2, positive 2. All right, on to number 17. This one's already set equal to 0 in standard form. So my GCF, they both are divisible by 4x squared. This leaves me with x squared, and this leaves me with, let me see, 16. This is a difference of 2 squares. The square root of this is x. Square root of 16 is 4. Once again, one positive, one negative. So this one I will show you the work since I'm able to set each one equal to 0. So divide by 4. And x squared equals to 0. And take the square root, x equals 0. This one obviously would be negative 4, and this one would be positive 4. And there was one where I said, yeah, you always divide first and then take the root afterwards here. Yeah, be careful of that. I feel like I said something about that earlier, but just be careful here. Yeah, like this one here, you would take, divide by 2 first, and then take the cube roots. All right, number 18. 4 terms, so we're gonna bring everything to the same side, so 2x cubed. I'm gonna add 8x squared to negative, that's gonna be positive 4x squared. And then we can factor out the GCF, they're all divisible by 2x, so that's gonna be x squared plus 2x minus 48. X method, 2, a is 1, 1 times negative 48 is negative 48. That's gonna be 8 and 6, with 6 being negative. So we have 2x, x plus 8, x minus 6 is equal to 0. So solutions, 2x equals 0, that's going to be 0. X plus 8 equals 0 is negative 8. X minus 6 equals 0. When you add the 6 over, you get positive 6. All right, on to 19, 20, and 21. It says to find the real zeros of the function. So when I looked at these, first off, I noticed there's 4 terms, but when I did factor by grouping, I noticed this had an x squared in common, this had a negative 1, but the parentheses wouldn't be the same. So you can definitely give that a shot, but I'm gonna go straight to the rational root theorem, and I'll walk you through the steps. So step number 1 is to identify all possible solutions. So for this case here, the possible solutions, I'm gonna find the constant term, which is negative 15, and the numbers that multiply to give us 15 are gonna be 1, 3, 5, and 15, right? 1 times 15 is 15, 3 times 5 is 15. Then we're going to find the leading coefficient, in this case is 3. The factors of 3 are 1 times 3. Now I'm going to divide all the constant factors by the leading coefficient factors. So 1, 3, 5, and 15 divided by 1 is just itself. And don't forget we put the plus or minus. For the 3, when we divide it, we don't want to repeat any, so plus or minus 1/3. 3 divided by 3 is 1, so I don't need that. 5 divided by 3 is plus or minus 5/3. And 15 divided by 3 is 5, which is already here. So I definitely need to be able to see this here. Step 2 is to perform synthetic division till I get a remainder of 0. So let's start with this. We have 3x cubed, so 3. We have negative 5x squared, so x squared minus 5. We have negative 47x, so negative 47. And negative 15 is my constant. So notice we had x to the 3rd, 2nd, 1st, and constant. So there were no missing powers. All right, so we talked about to speed up this process, we are going to plug it into Desmos so that we can find our pivot point that we need pretty quickly here. So we're going to type in 3x to the 3rd minus 5x squared minus 47x minus 15. And we're just going to pick one point, and I see this 5 is very nice to look at, so I'm going to pick 5. And that should give me a remainder of 0. So we drop the 3. 5 times 3 is 15. Negative 5 plus 15 is 10. 5 times 10 is 50. Negative 47 plus 50 is 3. 5 times 3 is 15. This was a negative 15, I forgot it. Negative 15 plus 15 is 0. So what this just proves is that x minus 5 is a factor and that x equals 5 is a solution. Step 3 is to take your quotient and write it as a polynomial. So since this is x to the 3rd, this will be x squared. All right, so we wrote our polynomial as a quadratic function. Now we're going to factor it. So b is 10, a is 3, and then 3 times 3 is 9 at the bottom. So my factors that add to 10 and multiply to 9 are 9 and 1. I can reduce 9 over 3 to 3. So now I have x plus 3 and 3x plus 1. So when I set each one equal to 0, these are going to be my solutions here. So x equals, the first one I have is 5. This will become negative 3, and this will be negative 1/3. All right. And if you want to verify your answers, once again, this is verifying. 5, negative 3, negative 1/3. 5, negative 3, negative 0.333 is negative 1/3. All right, let's go ahead and take a look at the next one, number 20. So for number 20, this one doesn't seem as tough. I could definitely use the rational root theorem, but what I notice here is they're all divisible by x. So first let's set this equal to 0, because we're going to solve it. Then I see they all have a greatest common factor of x. We do the x method here. I feel like we kind of did this one already, but okay. Then we have x minus 5, x plus 1. So when I set each one equal to 0, my solutions are 0, 5, and negative 1. All right, and now we're down to our last problem here for this page. So we have 3 terms, and I'm going to go straight to the rational root theorem because I can't see anything else to do. So my constant term is negative 48. My leading coefficient is 1. So I really just have to focus on this. So my factors, 1, 2, 3, 4, 6, and after that 6 times 8 is 48, 4 times 12, 3 times 16, 2 times 12, and 1 times 20, oh, not 12, 24, 2 times 24, and 1 times 48. All right, and the leading coefficient is just 1. So my factors, my possible solution would be plus or minus 1, 2, 3, 4, 6, 8, 12, 16, 24, 48. All right, step 2 is going to be to test. So I'll get this started right now. So x cubed is 1. There is no x squared, so we know we have to put a 0 in the spot. X is negative 28, and negative 48 is my constant. So let's go ahead and plug this into Desmos, and let's go ahead and find our solution so that we can speed up the process. So x cubed minus 28x minus 48. All right, so, oh, there's missing a 4. There we go. Yeah, this one looks good. 6. So I'm going to use 6 as my pivot point. That's going to be my first solution. Okay, so we drop the 1. 6 times 1 is 6. Combine. Multiply. Negative 28 plus 36 is 8. 6 times 8 is 48. And when I combine those, the remainder is 0. So this does check out to be a solution. Part 3, we're going to write it as a polynomial, as a quadratic. So x squared plus 6x plus 8 equals 0. X method right over here. So 6 dividing by 1. 1 times 8 is 8. Factor should be 4 and 2. So x plus 4, x plus 2. So my solutions, my first one was 6. Set this one equal to 0, you get negative 4. Set this one equal to 0, you get negative 2. And there you go. Sorry, that one's off the page a little bit, but there's the work to get that answer. All right, we're down to the last few problems here, 22 and 23. So to prove this one here, it has a remainder of 0, and to find that k value, we're going to do synthetic division. So x minus 5, we set that equal to 0 to get our pivot point of 5. X cubed, x squared, so 1, negative 1. We have for x, we have a positive k, and we have a negative 34, a constant. So we're just going to go through synthetic division. And at this point, we stop, right? Because k plus 20, we don't really know what that is. K plus 20, that's all we know. But we can go backwards from here. We know the remainder is supposed to be 0. And negative 30 plus 30 is 0. Now we know from past experience that 5 times whatever this number is supposed to equal 30. So in this case, 5 times 6 is equal to 30. I'm going to circle this. I'm going to write an expression based off of this to solve for k. So that's a positive k, positive 20 equals positive 6. So easily we just subtract 20 from both sides, and we get that k is equal to negative 14 as our solution. All right, for the next one, same process. X minus 7, we're going to set that equal to 0. We get 7. We're going to see that the remainder is 0, so we have 2x cubed, negative 13x squared, minus kx, that's negative k, and then positive 105. So we go through synthetic, drop the 2, multiply. 7 times 2 is 14, combine is 1. 7 times 1 is 7. Negative k plus 7, we don't know what that is. We know the remainder is supposed to be 0, so that this is a solution or a factor. 105 minus 105 is 0, and 7 times negative 15 is negative 105. So we're going to circle this because we're going to write an expression to solve this. So that is a negative k, that is a positive 7, equals negative 15. So first we start by subtracting 7, so negative k equals negative 22. We're going to divide by negative 1 to isolate k, and k equals 22. Okay, you notice I skipped 24 because I said that one was not necessary. All right, determine whether the binomial is a factor of the polynomial function. If so, factor the polynomial completely. So if you recall, the remainder has to be 0. Okay, so we're going to set this equal to 0, and we get negative 5 as our pivot point. Make sure there's no missing power, so x cubed, x squared, so 3 and 7. We have x and a constant, so negative 8 and negative 5. So at this point here, I'm going to start going through this synthetic a little bit quicker because we already kind of know how to do this. 35. Let's make sure I'm doing this right. So drop the 3, negative 5 times 3 is negative 15. 7 minus 15 is going to be negative 8, actually. Negative 5 times negative 8 is going to be 40. Negative 8 plus 40 is going to be 32. And then this would be negative 160, I believe. Leaving me with negative 165. So to determine whether the binomial is a factor, the answer right here would be no, because f of negative 5 equals negative 165, and that's not 0. Okay, let's try the next one. So set this equal to 0, we get negative 9 as our pivot point. X cubed is 2, x squared is 15, x is negative 23, and 36. So we drop the 2, Negative 9 times 2 is negative 18. 15 minus 18 is negative 3. Negative 9 times negative 3 is 27. Negative 23 plus 27 is 4. Negative 9 times 4 is negative 36. And this one, we do have a remainder of 0. So yeah, it is a function, yes. And if it is, we continue. So this is x cubed, so this would be 2x squared minus 3x plus 4. And we're going to factor it, so we'll do the x method. Negative 3, 2 times 4 is 8, and we're going to divide by 2. And look right here, I can't actually factor any further than this. There are no numbers that add to negative 3, but multiply to 8, because 1 and 8, 2 and 4. So my final answer is going to be x plus 9 and 2x squared minus 3x plus 4, since I cannot go any further than that. So yes, it was a factor, but I can't factor any further than where I've been gone. Okay, let's take a look at number 27. So we'll do the same thing, set it equal to 0. My pivot point is 2. So x to the 5th is 6, x to the 4th is negative 8, x to the 3rd is negative 6, x squared is negative 4. I don't have an x and I don't have a constant. So from here, I'm going to go through synthetic, drop the 6. 2 times 6 is 12. Negative 8 plus 12 is 4. 2 times 4 is 8. Negative 6 plus 8 is 2. 2 times 2 is 4. Negative 4 plus 4 is 0. 0, 0. 2 times 0 is 0, 0. So is it a factor? Yes, it is. And then from here, we have 6x to the 4th plus 4x cubed plus 2x. Okay. And pretty much here, what I'm going to do is I'm going to factor out the GCF here. They're all divisible by 2x, leaving me with 3x squared plus 2x plus 1. I can attempt to do the x method, see if it does factor any further. Well, let's see right now. So we have 2 at the top, 3 times 1 is 3 on the bottom, and we divide by 3. So are there any two numbers that add to 2 and multiply by 3? I'm going to say no. So my final answer is going to be, there's a 2x right here. This was x minus 2, my original factor. And then this one right here, so it's going to be this whole statement right here, 3x squared plus 2x plus 1. All right, so far we had 2 yeses and 1 no, so let's see what this last one is, number 28. Let's put this here, so x minus 6 equals 0, so it's 6. X cubed is 12, x squared is negative 69, and x is 39, which leaves us with a missing constant, so we put a 0. So drop the 12. 6 times 12 is 72. Negative 69 plus 72 is going to be 3. 6 times 3 is 18. Let me make sure I did this right. So drop the 12. 6 times 12 is 72. Negative 69 plus 72 is 3. 6 times 3 is 18. 47, this is going to be 57. I don't know what 6 times 57 is, so give me a sec here. Just work this out. So 6 times 57 is 342. And this gives me a remainder of 342. So at this point we say no, it's not. It's not because f of 6 equals 342, which means it is not a factor because the remainder was not 0. All right, and then now we're down to these last two problems, and they both are pretty similar. It says, according to the rational root theorem, which is not a possible solution of the equation. So pretty much we're just going to find the constant term. In this case, it's a 4, and the leading coefficient, which is a 3. So the factors of 4 are 1, 2, and 4. Factors of the leading coefficient are 1 and 3. So my possible solutions are plus or minus 1, plus or minus 2, plus or minus 4. And then we're going to divide by 3, plus or minus 1/3, plus or minus 2/3, and plus or minus 4/3. So then we take a look. Do we have a 4 here? Yes, we have a 4, so this can be the answer. B is 1/3. There's the 1/3. Negative 3, I don't see a 3 here, so that's a possibility. And then negative 2/3, that's right there. So my answer that's not a possible solution is negative 3. And last, we have number 30 here. Same thing, according to the rational root theorem, which is not a possible solution. So my constant term is negative 27. My leading coefficient is 24. So you see there's going to be a lot of factors here. So 1, 3, 9, and 27. So that wasn't too bad. For 24, we have 1, 2, 3, 4, 4 times 6, 3 times 8, 2 times 12, and 1 times 24. So that's quite a bit. All right, let's just start with this. We're going to divide each one by 1. So plus or minus 1, plus or minus 3, plus or minus 9, plus or minus 27. So let's see if any of these show up first. Nope, none of them showed up. So let's now divide by 2. Plus or minus 1/2, plus or minus 3/2, plus or minus 9/2, plus or minus 27/2. All right, so 8, 1/3. Nope. Okay, so let's divide by 3 now. So plus or minus 1/3. 3 divided by 3 is 1, which we already covered. 9 divided by 3 is 3, which we already covered. And 27 divided by 3 is 9, which we already covered. So we only got plus or minus 1/3. Oh, there's right there. So this is a possible solution, so that's not an answer. So now let's divide by 4. So we have plus or minus 1/4, plus or minus 3/4, plus or minus 9/4, and plus or minus 27/4. So as you can see, this could take a little bit longer. So let's see, 1/4. Okay, we have a 9/4, so we can get rid of this one. So now we're down to these two. So I'm going to go divide by 8 because this one has a division by 8. So plus or minus 1 divided by 8. Nope. Plus or minus 3 divided by 8. And we see that's a possible solution there, the negative 3/8. And so the only one that's not a possible solution is going to be B. And obviously you may have guessed that earlier just from noting that B simplified and maybe there wasn't one that was going to reduce to a 2. Okay. So that completes the review and what you were responsible for knowing on the test.